Hey everybody, today we are looking at 6.4. We are still working with parallelograms, but today we're going to look at three specific types of parallelograms. So the first one that we're going to look at is a rectangle. All right, so guys, this is why I was telling you to make sure that you are paying attention to the properties and kind of memorizing the properties as we go. Because today we're going to get three shapes. They're all parallelograms, so they will all have the properties of parallelograms. And then they're going to have properties of their own. So we're adding properties on top of properties. Okay, in a few days we're going to talk about kites and isosceles trapezoids and regular trapezoids, and they're going to have properties of their own. So we have properties just like all over the place coming out of our ears. So it is important, again, that as we go, you are memorizing the properties as we go and not waiting until the end, the day before the test, and trying to memorize all the properties in one shot. It is not going to work out well for you. Okay, so with a rectangle, okay, a rectangle is a parallelogram that has four right angles. Okay, so the definition of our rectangle, it's a quadrilateral with four right angles. We know it's a parallelogram because opposite angles are congruent, consecutive angles are supplementary. Okay, so we have a parallelogram with four right angles. So that means it will have all of the parallelogram properties. Opposite sides are going to be congruent, opposite angles are congruent, consecutive angles are supplementary, opposite sides are parallel, and diagonals will bisect each other. So it'll have those five things in addition to having four right angles. Okay. And then our diagonals are going to be congruent. All right. So that's a property that is specific to a rectangle, is that it'll have four right angles and it'll have congruent diagonals. Okay. So this is just showing us why it is a rectangle, or excuse me, why it is a parallelogram. All right. Because our opposite angles are congruent. All right. So we have a parallelogram with diagonals congruent and four right angles. That is information for a rectangle. So let's take a look at an example with a rectangle. Okay, we have an artist connects stained glass pieces with lead strips. In this rectangular window, the strips are cut so that FG is 24 inches, FH, which is the diagonal, is 34 inches. We want to find JG. Okay, so let's take a look. This is 24 right here for FG. All right, FH is 34. The whole thing is 34. So if FH is 34, I know that this piece is 17 and this piece is 17, right? Because the diagonals bisect each other because it's a parallelogram. So the whole thing is 34. Each of these pieces are the same. Now, I know that in a rectangle, my diagonals are congruent. They still bisect each other. So that means that all four of these pieces are all 17. Okay, so I know that FH is going to equal EG. All right, those are my diagonals are congruent. So I know that EG is also 34. And that JG is going to be half of EG. So that makes JG 17 inches. All right. So that is the first part that we're going to talk about with rectangles. Okay, so the big key thing that's new is that the diagonals are not only bisect each other, but they are congruent. All right, let's take a look at our next shape. Our next shape is a rhombus. A rhombus is a quadrilateral that has four congruent sides. So all four of my sides in a rhombus are the same length. Okay, it is a parallelogram because opposite sides are congruent. All right. Now, our key one here for parallelograms. We have two rhombus properties. Okay, we have, or three including the definition. We have that all four sides are the same length. That's our definition. Our first property deals with our diagonals, and that our diagonals are perpendicular. Okay, so our diagonals are going to intersect to form 90-degree angles. All right. our diagonal also is going to bisect the opposite angles. So like if this angle here is 100 degrees, then each one of these are going to be 50. Remember, if this angle is 100 degrees, my opposite angle is also 100 degrees, which means both of these are 50. So all four of my red angles here, 1, 2, 5, and 6, are all going to be the same because we're bisecting congruent angles. The same thing is going to be true with 8, 7, 3, and 4. That would make each of these 80 degrees, so each half of the angle would all be 40 degrees. All right? So our extra properties for a rhombus and for a rectangle deal with diagonals. So the diagonals of a rectangle are congruent, the diagonals of a rhombus are perpendicular, and they bisect the opposite angles. All right, so again, lots of properties. We need to make sure we are learning which ones go with which shapes. So we are told that our figures here are a rhombus. We want to find the measures. I want to find the length of VT. Well, our definition of a rhombus is that all four sides are the same length. All right, so if all four sides are the same length, I know these lengths are the same, which means I'm going to set them equal to each other. So I'm going to do 9x minus 11 is equal to 4x plus 7. Subtract 4x from both sides. I'm going to get 5x minus 11 over here and 7 over here. We are going to add 11 to both sides, and I'm going to get 5x is equal to 18. Divide, I'm going to get x is 3.6. So to find the length of VT, I'm going to plug that in. Didn't write the T. VT. Okay, and that is going to be the same length because VT is here. All right, it's the same length as any one of these. So does it matter which one I plug it into? Okay, no, it does not. All right, because all four are the same, so I can choose any of the expressions to plug it into. I'm just going to use ST, so it really doesn't matter. So VT is going to be 4 times 3.6 plus 7, which makes VT 21.4. All right. So again, a rhombus has all four sides congruent, set them equal, find x, plug it into any one of them, and that's the length of all the sides. All right, I want to find the measure of angle WSR, which is this angle right here. Well, I know that this angle is going to be the same as this angle because my diagonal is going to bisect this one, okay? But I only know this angle here as well. Well, this angle here doesn't have anything to do with this one here. But remember what else we know about diagonals of a rhombus, that they are perpendicular. So I know that this is a 90-degree angle. So I'm going to start by saying 2y plus 10 is equal to 90, okay? So I'm going to subtract 10 from both sides. I'm going to get 2y equals 80. Divide both sides by 2. I get y is 40, okay? I know that. All right, so now that y is 40, we are going to go ahead and take that and plug it in. So remember that, okay, the diagonals bisect the opposite angles. So I know that the measure of angle TSW is equal to the measure of angle RSW, which is what we want. All right. So I know that we're going to do y plus 2 is, and I'll write it the same way. I'm just going to rewrite the letters WSR. It's the same. Okay. So it's going to be 40 plus 2 is WSR. So 42 degrees is the measure of angle WSR. All right. And this one we used the property that all the sides were congruent. So if you want to make note of that, okay, and this is our property here. Okay, and then this property here is that the diagonals are perpendicular. So we've used all of the properties of a rhombus in these two examples. All right. Again, if you have questions, please let me know. All right, next one is a square. Okay. A square is all the things. Okay. It is a parallelogram. It is a rhombus, and it is a rectangle. All right. It is a parallelogram because opposite sides are congruent. It is a rhombus because all four sides are congruent. And it is a rectangle because it has four right angles. So a square has all of the properties of a rhombus, it has all of the properties of a rectangle, and it has all of the properties of parallelogram. Okay, so it's really important that we are showing all the things. All right. So whenever we're verifying that we have a square, all right, I'm gonna kind of slide down here. Okay. So for this example, I want to show that I have a square here. So in order to do that, I need to show a property of all three pieces. I need to show that it has the property of a parallelogram, it has the property of a rhombus, and it has a property of a rectangle. It's got to have all of the properties in order to show that it truly is a square. So in your notes, you'll notice that it says step 1, we're going to show that AC is congruent to BD. So we're going to start by showing that the diagonals are congruent. All right, which is our property of a rectangle. Okay, so step 1 is the rectangle property. So the way we're going to show that the diagonals are congruent is by using the distance formula. All right, so I'm going to start with AC. So the length of AC is the square root. Okay, now I'm just going to call this one x1, y1 and x2, y2. So I'm going to have x2 minus x1, so 2 minus a negative 1, quantity squared, plus y2 minus y1, so 7 minus 0, quantity squared. All right, this is going to be the square root of 2 plus 1 is 3, 3 squared is 9, 7 minus 0 is 7, 7 squared is 49. Okay, so AC is going to be the square root of 56. All right, then we are going to do BD. And I'm going to call this one x1, y1, this one x2, y2. So I have 4 minus a negative 3 for x1 or x2 minus x1. Y2 minus y1 is going to be 2 minus 5. Quantity squared. Okay, so 4 plus 3 is 7. 7 squared is 49. 2 minus 5 is negative 3. Negative 3 squared is 9. So again, we have the square root of 56. So I know that AC is equal to BD, which means that the segment is congruent. The segments are congruent. Segment AC is congruent to segment BD. Okay, so we know that it is a rectangle, or it's a property of a rectangle. Okay, step 2 is we want to show that AC is perpendicular to BD. Okay, that is our slope formula, and this is our rhombus property. All right, we are showing that if AC and BD are perpendicular, all right, we know that that is a property of a rhombus. Okay, so we've got a rectangle property, now we need a rhombus property. So I'm going to find the slope of AC. Okay, remember slope is y2 minus y1 over x2 minus x1. So it's y's on top. So I'm going to do 7 minus 0 over 2 minus negative 1. So we're going to have 7 over 3. So remember that I want my slope of BD to be the opposite reciprocal. So I want my slope of BD to be negative 3/7 to show that they're perpendicular. So let's check and see if that's what happens. All right, so BD, I'm going to do y2 minus y1 over x2 minus a negative 3 for x1. Okay, so 2 minus 5 is negative 3. 4 plus 3 is 7. So we know that AC is perpendicular to BD because the slopes are opposite reciprocals. All right. So we are perpendicular. Okay. The last thing we're going to do is show that they bisect each other, that the diagonals bisect each other, which is our parallelogram property. All right. To show that the diagonals bisect each other, we're going to do the midpoint formula. Okay, so this was distance. This is slope, and then this one is midpoint. So guess what? The time I told you that, hey, that the slope formula, the distance formula, the midpoint formula, we will literally use all year long. Here it is again in yet another chapter. Okay? So, to show that the diagonals bisect each other, I want to show that the midpoint is the same for both diagonals. So I'm going to first find the midpoint of AC. Okay, remember, midpoint is add your x's, divide by 2, add your y's, divide by 2. So I'm going to take negative 1 plus 2, divide by 2, and 0 plus 7, and divide by 2. Okay, this is going to give me that my midpoint, negative 1 plus 2 is 1. It's going to be 1/2 here, and 7/2 here. Okay, now we're going to do the midpoint of BD, and again, I want them to be the same. So I'm going to add my x's, so negative 3 plus 4 divided by 2, and then add my y's, which is 5 plus 2 divided by 2. Okay, negative 3 plus 4 is 1, so the x value is 1/2. 5 plus 2 is 7. So we have 7/2 here. So we know that AC and BD bisect each other because their midpoints are the same. Okay, so this is one way to show that a figure is a square. And this is just using the diagonals, okay? I didn't use any other properties. I just looked at my diagonal properties. Okay, so I've got diagonals bisect each other from step 3. I know that diagonals are perpendicular from step 2, and that the diagonals are congruent from step 1. Okay, so we've got our property of a rectangle, property of a rhombus, and property of a parallelogram. You have to show all 3 properties. Now, there are a multitude of ways that I could have done this, okay? I could use the sides. I can find the slope of all 4 sides to show that they all intersect at right angles, to show that I have a rectangle. When I do that, I will see that opposite sides are parallel. Okay, so if I do the slope of all 4 sides, that covers the rectangle property and the parallelogram property, because we'll see the opposite ones are congruent and the consecutive ones are opposite reciprocals of one another. Okay, and then I could use distance formula for all 4 sides, and that would be my rhombus property. Or I could mix and match. So like if you like, hey, if you like slope, you could do the slope of the diagonals to show it's a rhombus, and then you could do the slope of all 4 sides to show that it is a rectangle and a parallelogram. And that's one way you can do everything with slope. You can do distance all the way around. You could do the distance of all four sides to show that opposite sides are congruent and all four sides are the same. And then you can do distance formula of the diagonals to show that the rectangle is there. All right. So there's a way to use distance the whole time and slope the whole time. I think the way we've given you here is probably the quickest. But again, there's a multitude of ways to do it, and it's kind of up to you how you want to get there. But you do, again, have to show a property from each of the three figures, or you don't have enough. All right? So just please make sure that you are kind of paying attention to that sense. So let's take a look at the last page here. Okay, this is a kind of a breakdown of all of your properties. All right, you will notice in the right-hand column of your paper that it has all the parallelogram properties as well. All right, but this kind of puts all of your properties all together in one space so you can see everything we've done so far. Now, notice it is a lot of properties. So please make sure, again, that you are memorizing things as we go. All right, the next section, we're still going to be working with our special quadrilaterals, the rhombus, the rectangle, and the square. But then we will move after that to a different set of figures. So please make sure, again, you are memorizing these properties. I cannot stress that enough. Please make flashcards, do whatever you got to do. But unfortunately, you just got to memorize it. All right? So I hope you have a fabulous day, and I will see you guys later.